Right, let's take a look at some basicity trends. And so we're going to take a look at the pKa-H. Right, so we're taking a look at the pKa of the conjugate acid. So I'm just going to put the mean here, but note that we're not talking about the mean. So for example, when I say methylamine has a pKa-H of 10.6, what I mean is that the protonated version has a pKa of about 10.6. Again, it's very confusing, but that's the way it's done. So for example, something like that compared to aniline. If we think about this one, aniline has a pKa-H of 4.6. Remember that the larger the pKa-H, the stronger the base. So this NH2 is more basic than aniline, and this one is less basic. It's less likely to pick up a proton with that lone pair. And if we think about it, the reasons make sense. The lone pair on this one, instead of going out to pick up an H+, it can also participate in resonance within the ring. And so this lone pair is delocalized all over this ring. And since it's delocalized all over this ring, it's less likely to go after an H. So the general rule is if your lone pair is delocalized, you're going to have a less electron density there. You're going to be less basic, less nucleophilic. And again, the larger the pKa-H value, the stronger the base. We can make aniline more basic if we add electron donating groups. So for example, if you have NH2 on either side, then your pKa-H is 6.2. So now we've made it more basic. If we think about that, that makes sense. You have an electron donating group, so you have a larger amount of electron density. You're more likely to go after that H+. And then, of course, we can do the vice versa. If we withdraw some of that electron density from that lone pair even more by adding an electron withdrawing group, such as a nitro group, we'll get an even less basic compound. And then the final thing to note is that amines and amides are not the same, right? So we can see that amines are generally pretty basic, right around 10. Even aniline is somewhat basic, around, kind of 4-ish. This nitroaniline, not very basic at all. But amides themselves are just not basic. Its pKa-H is negative 0.4. And so this is just not basic. Or nucleophilic for that matter. And that has to do with resonance effects, of course. This lone pair on the nitrogen is delocalized over this oxygen, and oxygen is more electronegative, and so it's hogging that lone pair, and so it's not really allowing that lone pair to act as a base or a nucleophile. And again, the kind of rule of thumb here is that an amine and an amide are not the same thing. They are two completely, totally different functional groups. And we're talking about amines now, and so that's why we're saying basic. We'll still talk about amides here and there, but we did talk a lot about them in the carboxylic acid derivative chapter. So talked about amides as carboxylic acid derivatives. And amides themselves are actually somewhat basic, or somewhat acidic, my bad. So this one actually is somewhat likely to donate an H, right? Because then we can take that negative charge and delocalize it. And this has a pKa of about 17. Now I'm saying pKa here, not pKa-H.